Okay, good. Once again, you're most welcome, and we are in for pure mathematics. Please feel free to go in the playlist on our channel and enjoy a lot more of the topics. Please, you make sure you subscribe to the channel, share, comment. Where necessary, you can give a comment. It can be a supplement on what you think you must improve upon, like that. All right, so we are in for pure mathematics, topic vectors. Now, these vectors here, you all know, they set one question in A, one question in B. That is A-level standard. I mean that it gives you assured 17 marks. And it's a simple topic. Okay. Now, let's step in for lesson 1. So we are saying that, by definition, a vector is a quantity with magnitude and direction. A vector is a quantity with magnitude and direction. Then they are saying that a vector AB is denoted by AB with an arrow up or AB with the wavy line. So when writing a vector, you can be this or this, but for the course of our topic, we shall be using this. It is simple like right. A wavy line or this, that all means a vector. So a vector has got both magnitude and direction. I explained this last time. What we mean, like say for example, okay, in the world of vectors, what must we know is that if you have a school, I want to explain this. If you have a school, and maybe this is your home, and from your home to school, we have 10 meters, just assuming 10 meters. So now, if they ask you, what's the distance from school to home, and the distance from home to school. Now, in the world of vectors, here we say the displacement covered will be 0. Why? It's because if you're moving from school to home, look, from school to home, like this, from school to home, it is positive 10. But from home to school, it is negative 10. Therefore, you add 10 plus negative 10 will give you a 0 meters. Now, the word magnitude means these 10s you're seeing here. Then direction means that negative. Any change in direction in vectors, we attach a negative. That's what we mean by vector is a quantity with magnitude, which is 10, 10, and direction. So direction is 10, like direction school to home, home to school. Change in direction, attach a negative. That's what we mean by vectors. Okay. The denotations are there. Okay. Now subheading, position vector and a column vector. Now you all know what we call a position vector. Now, a position vector means that is coming from the origin. So if you have the Cartesian plane, y-axis, x-axis, and the origin has got a coordinate 0, 0. We all know that now. If a certain point A is plotted in a Cartesian plane somewhere, so its distance from the origin, that point A, is what we call position vector OA. We call it a position vector OA. And how do we write it? We write it in column form. Column means in this order. This one here is in row form. Row, this one is a column. So vector OA will be equal to x, y. But the coordinates are written in row form, just like we have it there. Okay, good. Now, an example of this is just you having a coordinate, like say for example at A, 2, 3. Then they say OA is equal to 2, 3. As simple as that. Okay, note. Vectors can also be in 3 dimensions. All right. Now, can also be in 3 dimensions. We mean dimensions in simple terms. It may mean sides. Like, this is 2 dimensions. What do we mean? The x dimension and the y dimension. That's why there are 2. X, y. But then we are saying they can also be in 3 dimensions. The y dimension, the x dimension, and the z dimension. Now, this is what brings us to A level. In O level, we don't go step in for this. Now, for y, it remains. For x, it remains. Then we bring in another new guy, which is z. You see that here, we had the x, y for 2 dimensions. You only add the z to make it 3 dimensions. Therefore, the position vector OA. Similarly, I'm only relating to this. It's not anywhere here, but I'm only relating to this, that if you want to OA again, your OA position vector will be equal to x, y, z. It is now in 3 dimensions. Dimension x, dimension y, dimension z. That's how we write it. But then, there is something you must know also. Like, say, for example, here, in 3D, we have other letter names we use. Like, for x, we call it, Yep, for x, we call it I. This is how I write my I, please. This is how I write my I. My I is like this. Then my J, okay, that is my I now. Some people understand. Then my J, this J of yours is that. That's how I write. My I is that. My J is that. You will help me and comply with that. So now the X is I, the Y is J, and the Z is K. And that one gives us what we call the IJK font notation. So therefore it means that if you want to write vector OA will be the same as X in the I plus Y in the J plus, okay, Z in the K. You put a wavy line because those are vectors. You put a wavy line. Please, that's how we write. In IJK format, we connect them using a plus. So that is XI is equal, OA is equal to X in the I plus Y in the J plus Z in the K. Now this one is the same as this. It is the same. Except for example, let's give an example here. We shall write some of the coordinates. If I write, say for example, 2, 3, 4. How do we write this in the IJK format? This will be 2 is in the I. So you say 2 in the I plus. Whenever I come into this, you put a plus. Plus 3 in the J plus then 4 in the K. I don't know if I can see that. So that, but you put wavy lines on this to mean that they are vectors. So you must be familiar with this notation: 2, 3, 4, 2 in the I plus 3 in the K plus 4 in the J. Which other example can we sample here? I'll use this area here to help us all so that we can learn how we can have that understood better. Another format can be, like say for example, in the IJK format, we can write it as, okay, 2, -5, 3. Now this one will be written as what? 2 in the I. Now when you have a negative, just put -5 in the what? In the J, then you say plus 3 in the K. Another format of writing will be, say, 2, 0, 2, 0, maybe 1, like that. This I write it as 2 in the I. Now where you see a 0, you don't put. Where you see a 0, you don't put it. You just skip and go to, remember this one is I, this is J, this is K. Now where you see a 0, you don't put, you just go to this. So it will be plus. Now 1 in the K, you just write the same as, just write it as K. So whenever you see that you have I, then from that I've gone to K, you just saw the one that I've left out is a 0. Take note of that, okay? Let's now go to examples. Algebra vectors. Now, algebra vectors here, we mean how can we add vectors? How can we subtract? I didn't want us to waste time with this because I know it's very simple. That's why I didn't go ahead saying addition of vectors, subtraction, multiplication. I've just put everything here in the examples. So algebra vectors, right? Say that if vector A is equal to 3 in the I. By the way, this is read as 3 in the, this is read as 2 in the I minus 5 in the J plus 3 in the K. Not 2I minus 5J plus 3K. No. All right. So A is equal to 3 in the I minus 2 in the K. Now I think we have here I, and next we are going to K, meaning that the J is 0. All right. B is equal to 2 in the I plus 3 in the J minus 5 in the K. Find part A plus B. Vector A plus vector B. Shall say solution. We've got no problem with that. Solution. Now let's write them in column form. What would be my vector A in column form? My vector A in column form, where are you? Vector A in column form. We have 3 in the I, 2 in the K. So 3 in the I is there, the J is 0, and -2. That's what you have, comma. Vector B is simply equal to, all right, 2, 3, -5. You can relate with that. Now adding them, you're going to add this plus this. This will now be, okay, 3, 0, sorry. 3, 0, -2 plus, we are having a 2, 3, -5. Please, we add them up. Which answer shall we have? Now you see that a 3 plus 2 will be a 5. A 0 plus 3 will be a 3. A -2 plus -5 will give you a -7. Where necessary, can use a calculator. Where necessary, can use a calculator. We're adding vectors like that. All right, good. Now, let us proceed. This side we have now A minus B, but we already have them in column form. So A minus B will be just this minus that vector. We have them in column form. This is 3, 0, -2, then 2, 3, -5. Subtract. What are we going to have? 3 minus 2 is 1. 0 minus that is -3. -2 minus -5 will be 3. Please use a calculator. Negative 2 minus negative 5 will give you 3. Okay, done with that. Let's now come to this. We have 3a plus 4b. So 3a means 3 into the a is 3, 0, 2, plus 4 into the b is 2, 3, 5. Multiplying, we shall have 3 times 3 is 9, 3 times 0 is 0. Reduce this a bit. 9, 0, 3 times 2 is a 6. Okay, plus multiply 4 times 2 is 8, 4 times 3 is 12, 4 times 5 is 20. That's what we have. Then you can add finally 9 plus 8, that is a 17, 0 plus 12, that is a 12, 6 plus 20, that is a 26. Okay, and as simple as that. You can also try out this one here and you see which answer will come out. Let's proceed with more examples. All right, so still we're continuing with our lesson. Now we have what we call displacement and magnitude of a vector. So displacement and magnitude of a vector, we shall now look at this. First of all, let's begin with displacement. Now, okay, with displacement, okay, we shall look at this. We shall look at this. This being the x-axis and this being the y-axis. Now, in simple terms, what we mean here is, like, say, for example, what if I have a certain point, say A, at that level, and another point, say B, at that level? What if when you move from A to B, they mean that you have displaced yourself from A to B, like that. But you all know that this point here is always the origin. Now, by it being the origin, what does it mean? Like, let's connect from the origin up that very point B, point A, and from origin up that point B. Now, it's that you have displaced yourself from A to B. Let's see. How shall we get a displacement? This means that you have moved from that to that. Then also, we are moving from there to that. So, a little bit, make it stronger. You see that? Now, it means that the position vector from A to B and from O to A, how shall we get it? It means that what if when one wants to get this? Say for example, what if when one wants to get, like say for example, the vector of the displacement of AB, in simple terms, how can someone move from A to B but without using a shortcut AB? Okay, you realize that? Okay, to move from A to B, we shall start from A. It means that you can move from A to O. You can move from A to O, that is a vector, plus from O to B. That is from O to B, like that. Now that's what we have. But remember, in vectors, you look at AO, it will be a negative. Therefore, once you have OA vector, that means that once you want to call it O, once you want to call it A, or then you attach a negative. Any change in direction, you attach a negative. Then that means that we shall have that vector AB will be equal to negative. Now I want to change this. That where you see AO, the reverse is true. AO, and say AO is also the same as negative OA. By the way, let's take that. Because you can divide both sides by negative, and it can be true. So you shall say that negative OA, since if you want to correct direction here, then once you change the order, it is AO positive. Once you want to start with OA, you attach a negative plus B. But it's always good to start with the positive. So AB vector will be equal to OB, the positive, minus OA, like that. So now this one here is the formula for displacement. So times when they will be asking for AB, you just know we say OB minus OA. The logic is start with this minus that, and it comes from there. Now this is what we mean by displacement. Let's now go and see what we mean by magnitude. All right, what we mean by magnitude in simple terms, we shall also consider a Cartesian plane. In that order. and magnitude of any point, say A, B, X, any other point in the Cartesian plane. So this is x-axis, and this is y-axis. So we are considering a point, say for example, this is our point A, like that. Our point A, there. Now, you realize that that's point A, we want to get the magnitude of that point A from the origin. So the origin is 0. Now, shall we get the magnitude of that point A? Now, realize that if you come and drop a perpendicular from here, a perpendicular from here like this will give us an angle of 90, like that. Now, I want to get the length from here. I want to get the length from here up to there. Let me even make it highlighted. I want to get the length. The length is the same as magnitude. I want to get the length from here up to there. All right, good. But remember, from here up to here, since you're moving in y, we shall call it y. Then from here up to here, since you're moving in x, we shall call it x for simplicity. Now, what you want to get is magnitude of OA. And magnitude of OA, we denote it as magnitude of OA, we write that as that. That's what we want. Then how shall we get it? We shall use Pythagoras theorem. And now we shall say that OA, shall say OA squared is equal to, let's square this area, x squared plus y squared. Now from there, we shall introduce a square root, So therefore we shall have that. Now this square root of that will give us now the magnitude of OA. The magnitude of OA is equal to a square root of, x squared plus y squared. That implies that whenever they ask you to find the magnitude of a point, this OA is having a coordinate. The coordinate will now be x, y. Any value with the two coordinates, all coordinates in 2 dimensions, to get its magnitude, you just take this formula here. So this is the formula for magnitude of OA. So now here we shall now say that this means magnitude of OA. Magnitude of OA in simple terms. All right, good. Then we shall say, if this is for 2 dimensions, vectors in 2 dimensions, we shall now say that similarly, comma, for when OA is equal to x, y, and z. Similarly, when OA is equal to x, y, z, then the magnitude of OA will be got from. Now we know that once you have x, y, you just go on squaring and you add. So to be a square root of, you come and say x squared plus y squared plus z squared. And that's how we get the magnitude of vectors in 2 dimensions. All right, let's again proceed. Something else. Okay, great. So let's wind up with this and we see the way forward. So therefore here, we are now going to have Roman number 1 says, all right, so they are saying that A is 3, 4, and they want us to get the magnitude like this. So we shall now say that from the magnitude of A, when the values are unknown, is equal to, once it's in 2 dimensions, x squared plus y squared. That's what we do. So the magnitude of A in simple terms will be, all right, equal to a 3 squared plus a 4 squared. Now then what are we going to have finally? That's a 3 squared. Please, you can just put direct in the calculator. Plus 4 squared, put direct in the calculator. This will just give us a square root of 25. Give us the square root of 25. The answer you have is a 5. But then that's not just enough. You now add the word units, and that's how we get the magnitude of that vector. Let's now come to this. We have B, that is the therefore magnitude of B. Since I've already defined it here, the magnitude of B I've already defined it. So it will be equal to a square root. Now negative a half. Please learn to use brackets. -1 squared plus a 2 squared, like that. So this will now give us a square root of, in simple terms, 5, because -1 squared is 1 plus a 2 squared, which is a 4, gives us a 5. Then here you can give us the square root of 5 to 1 decimal, rather to 4 decimal places. acceptable. So 2.2360. Okay, 2361. You add that the word units. These are just something. This is just something simple like that. Okay, now let's come to this side. You want to get magnitude whereby they are in 3 dimensions. You have 1, 2, 3. So therefore, that means that the magnitude of r will be in simple terms the same as this. That value of x squared plus value of y squared plus the z also squared. Then, what are we going to do next? We're going to say that magnitude of r is as good as a square root of 1 squared plus 0 squared plus negative 3 squared. All right, good. Then there, what are we going to have? So magnitude of r will be as good as a square root of 10. 1 squared is 1 plus 0 squared is 0 plus negative 3 squared is 1. So I'll give it 10. Now here it will give us a square root of 10. Okay. Square root of 10. That is a 3. Please, you can also be trying out on your calculator and see. It's 1, 2, 2, 3. You add the word units to that. Okay. Lastly, you have this. Therefore, we shall have that magnitude of q is just equal to a square root, a negative 3 but squared plus, all right, a 7 but squared plus a negative 5 and also squared. Which answer are we going to have here? So in simple terms, if I try to simplify this, will give me 9 plus 49. 7 squared is 49, not 14. Please use a calculator. Plus this will give us a 25. Now when we try to add, that will be a 4 and 9 plus a 9 plus a 25. All right, that will be 83. So now square root of 83. Then which answer shall we have? Units. So there are 4 square root of 80. That will give us a 9.1104 units. A 9.1104 units. As simple as that. Don't forget to subscribe.